Okay, so I'm going to go through some ACT problems, and then I'll do some of the homework problems that I think you might get stuck on. So let's look at this one. So we're going to use this trapezoid right here to answer all of these questions. So this first question, it's asking us what the slope of CD is. So CD, that's going to be this right here, right? So that slope. Which this we're actually doing right now. So slope and rate of change are very similar. So slope, if you remember, is rise over run. Okay, and I'm just going to start from C, and go down to D. Okay. So this is obviously going to be a negative slope. So my rise here, I'm actually not rising, I'm going down, right? So I'm going to go down from 4 to 1, so that goes down 3. So the rise is actually negative 3 because we went down. The run, so I went down 3 there, and then I'm going to go right 3 here. So negative 3 over 3 is negative 1. Cool? Okay, this one. So when ABCD is reflected over the y-axis, so that means it's going to reflect over this line right here. So we're just going to flip it this way. We want to know what the D coordinate is going to be. So this is going to be over here somewhere, a little bit further, but I'll be off the screen if I draw it. So the y coordinate stays the same. So if I look at all these, the only one where the y coordinate stays the same is F right here. So it must be F, because if we reflect this, instead of going to 12 on the positive x-axis, we're just going to go to 12 on the negative x-axis. Okay, this last one. So we want to know which of the following vertical lines we can cut this into two trapezoids with equal area. So I'm just going to kind of test these first and see if there's any that we can eliminate. So 2.5, well, that would be like right there. Obviously, that one's not going to work. 3.5, similar thing. I still don't think that works. 4.5, maybe, I don't know. 5.5 and 6.5, somewhere in there. These two are the two that I think we should check. So now I've narrowed it down to 2 of these. So I'm just going to erase all of this. Okay, so let's check 6.5 first. Or either one. I guess it doesn't matter. But so if we look at this, 6.5 is probably about right there. Okay. And if you're like me, you might not remember the area of a trapezoid. Whenever you don't remember areas of something, break it up into triangles, okay? So first, let's figure out what these points are here. So like this point right here and this point right here. So the x value here is 6.5. The y value for this point would be 4, and this would be 6.51. Okay, so let's find the area of this side. I'm just going to do it by making 2 triangles there. Okay, so the height for both of these triangles is going to be whatever this height is, so it's going to be 3. So that means to find, like this triangle right here, well, the base, this would be our base, that's going to be from 3 to 6.5, which is 3.5. So that's going to be 1/2 3.5 times 3, which I did this earlier. And what did I get? Maybe I don't know what I got because I can't find my paper. Oh, there it is. I got 5.25. Okay. And then I'm going to do the same thing with this one right here. So then this is going to be, let's do it in a different color. The height is still the same, so we still have a height of 3. And then our base here is going to be from 2 to 6.5, so this is going to be 4.5. So this is going to be 1/2 4.5 times 3, because the area of a triangle is 1/2 base times height, which 1/2 4.5 times 3 is 6.75. We could add these together if we wanted to, and we end up getting 12. Okay, so this part is 12. Well, let's test this side. So again, we could break this up into 2 triangles. So this one, we have a height of 3. And then from 9 to 6.5, this is 2.5 and 3. So we have 1/2 2.5 times 3, which equals 3.75. And then this one, so again, we have a height of 3. From 12 to 6.5, that's 5.5. So the base here is 5.5. So this is going to be 1/2 5.5 times 3, which is 8.25. Add that together, 0, 1, 0. It's also 12. So that means that the line that cuts these in half would be 6.5. And say that we checked 5.5 first. Well, you would realize that it's a little bit off, and then you wouldn't even have to check 6.5. You would just assume that it's true. Okay. This is a lot like what we're doing. So first, you always work inside out. So F or G of 1/2. So I'm going to take the G of 1/2, and I'm going to plug in 1 over 1/2, which this is really saying 1/2 goes into 1 how many times? It's 2, or you could rewrite this as 1 divided by 1/2, which we can then flip this. So this would be 1 times 2 over 1, which equals 2. Okay, and then we're going to take this 2 and plug it in for F. So this will be F of 2, which will be 2 minus 1/2, which 2 is the same thing as 4/2 minus, 1/2, which is 3/2. Okay, that took a little longer than I thought it was going to, but there you go. Let's get to these next problems. Okay, so this one, I've already gotten a couple questions on this. That's why I want to go through it. So we are given this interval, and we want to find the average rate of change. So average rate of change, that's your change in Y over your change in X, right? These are our X values. We have to plug this in to find our Y values. So I'm just going to do, this will be like F of 4 plus H minus F of 4 over 4 plus H minus 4. Okay, so then if I plug in 4 plus H, I'm just going to do it down here. So F of 4 plus H, I get 4 plus H squared plus 8 times 4 plus H, which that's going to be 16 plus 8H plus H squared plus 32 plus 8H, which ends up giving us H squared plus 16H plus 48. So that's what the first part of this equals. H squared plus 16H plus 48. If I plug in F of 4, I get 4 squared plus 8 times 4, which is 16 plus 32, which is 48. So this is going to be minus 48 over 4 plus H minus 4. So there's some things here that are going to cancel out, right? Like these 48s are gone, the 4s are gone, so I'm left with H squared plus 16H over H, which then these H's cancel, and my answer is H plus 16. Okay. This one shouldn't be too bad. I just don't think a lot of you know where the E button is in your calculator. So this is our city's population. And E is a number. It's a number. It's a lot like pi that pops up a lot. E is approximately 2.71828, blah, blah, blah. Okay. So and to do this in your calculator, so if you have one like mine, which you should, and there's one on the computer if you can't find it, but this is the second and then the division sign will give you E in the calculator. Okay. So if we were to do this one, it says that T is the number of years after 2000. So 2027, this is 27. This would be T equals 27 because that's 27 years after 2000. This would be T equals 32. Okay, so then this is going to be, we're going to do P of 32 minus P of 27 over 32 minus 27. And then you go through and simplify that down. And I think you guys can do that. Make sure to use the E in the calculator. Okay. All right, this last one. Okay, so you're going to see this a couple times. This, so f of g of x. That's the same thing as f o g of x. Okay, and like g of f of x is the same thing as g of f of x. Okay, so this is saying we're plugging f of x into g. This is saying we're plugging g of x into f. So if we do this one, so we're plugging g into f. Wherever there's an x, we're going to plug that in. So this is going to be 1 over 5 over x plus 2 minus 2. And we can just start simplifying this. Well, this 2 minus 2 is going to cancel. So I'm left with 1 over 5 over x, which that could be written as 1 divided by 5 over x, which we can then flip this. So this is 1 times x over 5, which is x over 5. Cool. Let's do it the opposite way. So now we're going to take this and plug it in over here. So then this is going to be 5 over 1 over x minus 2 plus 2. Which let's deal with this division part first. So this is the same as 5 divided by 1 over x minus 2 plus 2. I can then flip this. So this will be 5 times x minus 2 over 1 plus 2. Which really, we don't need this 1 here. So this is going to be 5x, because if I distribute this, minus 10 plus 2, that's going to be 5x minus 8. So then this answer is 5x minus 8. Cool. Okay. Bye. Miss you guys.